Okay. So I hope that the overall idea and the way to look into things and have the always critical about what we are doing, what we are looking at, what we are understanding, and how we have to confidently make use of that understanding from the problem itself to give us the steps to go further with what are all the things that could be done as more information or more data or understanding everything. Okay.
Okay.
So you are doing that for all the thing, right? Not only for
Yes.
mathematics. Okay. Okay. Keep that. Last time, do you remember you made two mistakes? Do you remember them?
Yes, uncle. The logarithms.
No, logarithm we looked into later. I don't think you made a mistake with that because first time
Yeah.
you were introduced with the logarithm. I'm not talking about that. Even before going into that, I remember, that was in the even beginning of our session, there were a couple of mistakes. Do you remember that?
Yes, uncle. The square root. I told it a square root instead of
No,
this
not the
root of.
square root. Actually, I wrote x raised to the power of a.
Yes.
But you said that it is like x squared, right?
Yeah, it is a times, not.
Yeah, okay, that one, okay, you recalled. So the mistake was, you can see the whiteboard, right?
Yes. Yes, uncle.
So I asked what is the meaning of this, right? Mathematically, we should not do anything else. Like what is written there, we have to digest that. Okay, by looking at that, we take the information, everything is there, and we have to completely digest that. And that will actually let us to know that this is actually a variable in the name of x, and it has a rise to the power of a, because the a is written on the top right corner in a smaller size font size than the main variable x. That has a mathematical representation, and we need to understand that what is the meaning of that. X is simply a variable, and anything written on the top right corner, and that value is actually representing the rise to the power of, or index, or the exponent. So if this is the case, then we need to understand that this is simply, what is the meaning of this?
It is x multiplied a times.
Okay, no, x is multiplied with itself
Yes. Yes.
a number of times. Okay, x times a, it is ax. Okay, so here we
Yes.
are talking about x multiplied with, okay, there are different ways of writing the multiplication. One form is like you can put a cross, but in algebra normally we don't put the cross,
Put a
because what
dot.
happens, yeah, because the cross may look like
Look
capital
like an
X.
x.
That's the reason we
Yes.
don't do that. But we should know that even this is possible, and it is repeatedly multiplied. Actually, x is repeatedly multiplied a times. That is the meaning. So the most better way to write this is x middle dot, right? Middle dot is actually multiplication. So dot 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 and multiplied, that is a times. You see, all these are all same representation, or it could be within the bracket, right?
Yes, sir.
Okay, it can go many times with x itself. This is also the same. So a times. So this was the one thing. What was the other thing?
The other mistake I am not
Actually,
sure.
I tell you, bit difficult for you to recall. I was asking something, what is this? Then immediately you looked at the previous thing, what we have done. You were repeating exactly what was done earlier.
Yes. Yes, sir.
Yeah, okay. So that is what I said. Don't, like, if something is provided to you, let's say, okay, tell me what is this? This is uh, x a. What is the meaning of this?
Okay, so it is.
So the one on the left, okay, I call that as a second case. So one on the left side, the case number 1 is x raised to the power of a. So mathematically it is a representation and we know the meaning of that and we have discussed about that. Now I have written a second totally different, okay. You should not like, okay, something written, something looking similar to the left hand side. That is not the thing here.
No, it is not the same because it's
Yeah, we have to do, yeah, here x is a variable, yes, okay, but there is a subscript a, that is lower right bottom corner, smaller letter a is written. What could be this? Have you not seen the
divided by
subscript?
itself.
Okay, so you see this is the mistake I was telling. So you are want to give a meaning or understanding from this understanding, like something written on the top right corner as a meaning, the bottom right corner will be the opposite meaning. But in mathematics, tell me, the position is the opposite one.
No.
Then why your thought process is going like that? Tell me in mathematics what is the beautiful thing, like very very basic thing. Something is, no, this is a representation, and what is the opposite to that? Tell me that. Very basic one. Mathematically, it has to be meaningful mathematically. Don't confuse yourself. Don't go too much advanced or something. Go to very basic thing. Basically in mathematics, what is the first thing we learn? Numbers, right?
Yeah.
Numbers. With the numbers, we never learned anything like opposite of a number. There is nothing called opposite of a number, right?
Yes.
But number itself, if I write a quantity like, okay, let's put it as a third possibility. Let's say I write a number like a 3. What else we know about this? This is the number 3, but is there anything more information than what is 3 is? What kind of number is that?
Okay, so it's a natural number.
Yeah, okay. Why it is? Why something is called a natural number? What is the meaning of a natural number?
Natural number, it starts from 1 till infinity.
Okay, again, these are all definition. You have been forced to memorize that. But what is the understanding of that? What you understood, like why they are called natural numbers, and why it starts with a 1, and why it goes to
Usually we start counting from 1. We don't start from 0.
Okay, so the first number is a 0. There is no number lower than 0?
No, it is there. Then we have.
Okay, then use all these arguments like, okay, what is the beauty of this 3? Still you can't get it. If you start from 1, why you are going in the like you counting 1, 2, 3, right?
Yes.
You can also count like other side, right? Like 1, 0, minus 1, minus 2, minus 3 is also counting, right?
Yes.
What is the difference between the two?
That's the negatives, and this is the positive value.
Yeah. So what is the generic understanding? So you are having a good idea about natural numbers, right? Natural numbers, good. And then we go to no. Are you sure natural number starts with 1? What is the difference between natural numbers and whole numbers?
Whole number starts with 0.
My understanding is the other way around. Whole number is from 1, 2, 3. Natural numbers are 0, 1, 2, 3. Anyhow, I mean that is not a big thing here. You can check it, double check that. That is not a big thing. So it goes like, okay, why I am saying so? I keep my understanding. Okay, so the natural numbers come next to the whole number. So the natural number is not the first one what the humans have understood. They started counting like 1, 2, 3, 4. Like
yes.
Any counting means, I'm going back the same thing what we discussed in the very beginning. Any counting means it has to be about the same object, item, or the quantity, or the measure, anything, the value. Like, okay, 1 apple, 2 apple, 3 apple, 4 apple, like that. Okay, so that is why they are all whole numbers. So humans started with this understanding, right?
Yes.
Then they have to be of the same type. Like example, 1 apple, or one, for example, 1 centimeter, 2 centimeter, right? Always remember that. Don't ever give up on that. Okay.
Yes. Yes.
Now, how the 1 centimeter is possible? You are measuring something using a ruler or something starting from 0 centimeter. Get that?
Yes. Yes.
Only from there you can go to a 1 centimeter. So the 0 is important. That becomes the like natural numbers. So 0, 1, 2, 3. This is how we should have started everything. So that helped us to form the, so I call this as the natural number. Okay.
Okay.
Naturally, there is a 0. Emptiness is there. From only the emptiness. Only if there is no apple, 0 apple, you add a 1 apple, it completes. It becomes a 1 apple. Okay. So there also, so here it is all incremental counting. So these counting like natural numbers, whole numbers, all going in one direction. That is called either a plus or the positive direction. Do you get that?
Yes, sir.
Plus direction. The direction is an extra information. So the question I posed was 3 means in front of that there is a plus. You get that?
Yes. Yes.
That has to be immediately come to an understanding, because there is an opposite direction for the real numbers. We call that as real numbers. So there is a -3 also possible. Right? But
Yes, sir.
conventionally, historically, classically, we started writing numbers without a sign in front of that. We realized that there is an opposite direction also. Then to give a meaningful difference between a 3 and a positive 3 and a negative 3, they have to add a sign in front of the -3 or a negative 3. Do you get that?
Yes, uncle.
So the 3 without any sign is actually our +3, right?
Yes.
So this is the first thing we learned, the opposite direction. Do you get that? The plus and
Yes,
the
sir.
minus unary operator, that is the very first, like plus is one kind of operation, like it is actually representing the direction of a quantity. Then minus is the opposite direction of that same quantity. Do you get that?
Yes, uncle.
Like plus 3 rupees is a money I have. Minus 3 rupees meaning is a money I borrowed or I spent the money. You get that?
Yes, uncle.
So the plus and the minus is actually the basic mathematical forward direction and the reverse direction. So that should be the understanding. Like for example, x raised to the power of a, I take a small room here. If you know the meaning, actually this is nothing but x raised to the power of plus a. You get that?
Yes, uncle.
So if x power a, which is actually x raised to the power of plus a, is meaning is x repeatedly multiply itself a number of times, then there is a x raised to the power of minus a is also possible, right?
Yes, uncle.
That is what the opposite of this. Opposite is what? Here positive a means repeated multiplication, negative a means repeated division.
Division. Yes.
You see that? So this will look like 1 divide. Okay, 1x divide by x divide by x. Do you get that?
Yes.
Divide by x. Like how many times? A times. So not that x, a, subscript is totally different. You get that?
Okay. Yes.
It is a different representation. It is taking a different, okay, as you go, you will see that like x can have a here, a here, a here, a here. Can you believe? When you go to like in engineering or in physics or in mathematics, maybe in the 4th year or something, you will see a quantity like this.
Okay.
Because we need to represent in one way or the other, right? Everything got its own meaning. But at least in the school level, this x raised to the power of a is learned maybe 7th standard or something, or 6th standard, when you learn x squared.
I think 7th or 6th.
Okay,
Sixth,
7th or 7th. Okay, okay. But even before that, I told you, like very beginning, when you learned a variable like an x, maybe the x quantity may be representing something, maybe the number of apples, but the number of apples maybe which is already in the basket, and maybe after some time, like a day or so, we go and buy some apple and we add to that already existing one. So we need to have another variable for that, right?
Yes, sir.
So the one which was already there, maybe it's better to put it as a 0, because that is a reference point, because the basket, fruit basket, was already filled with so many number of apples. Then after a day or so, we added some other number, we bought it from the market. Do you get that?
Yes.
So the subscript is a representation of a similar kind of quantity, but we need more than one of them, then we use the subscript. So do you see that x base a, the subscript a?
Yes, sir.
It is similar to the, why only the number? It can have a variable like this also, look like a variable, but it is just x base a. Do you get that?
Yes.
Okay, it could be like, okay, I mean T A, T B. Tell me what could be the representation here. Capital T is used for?
Time.
No, time. Okay, I think I might have mentioned that there are something like instantaneous. Instantaneous and fixed or constant. Okay.
Okay.
What is the meaning? Like if you take a battery, it is a DC battery, right? Because it could be like 1.5 volt. It's fixed. That's it. This is the positive side and this is the negative side of the battery. And this 1.5 volt is fixed. Let's say you draw that graph with respect to time. All the time, this battery voltage will be, this is the voltage, and this voltage will be always, this value is 1.5. Do you get that?
Yes, sir.
So that means, graphically we can represent that, but this particular thing is independent of our time. This means this is a fixed value. It is a constant value. It is not going to change. Do you get that?
Yes, sir.
But we may, the 1.5 volt, let's say we add one more 1.5 volt, then what will be the value for this?
3
like
volt.
One battery, 3 volt. It can completely a different battery. Do you see that?
Yes.
So this value got changed from 1.5 to 3 volt because we changed the battery, but this is not because of change in the time. Right? We could add even 3 batteries, it could go 4.5 volt, it could take any value, right?
Yes,
So
sir.
that is why we use a particular variable, we use a capital letter for that. We put it as a capital V for DC voltage. You get that?
Yes, sir.
But for example, if it is a AC, you know what is AC, right? Have you seen the waveform like this?
Yes,
No?
I have, but I have not seen it in this battery. Actually.
Okay, so you have not yet connected. In mathematics,
No.
you have seen a waveform like this, right?
Yes. Yes.
Okay, so here it could be even this, the volt. Now we cannot write the capital. We have to use a lowercase because it is instantaneous. With respect to time, in the same circuit, it can vary. Do you get that?
Yes, sir.
Like our AC, like we get our power supply, right? The electrical power supply we receive from our wall socket for our domestic. We say that it is a AC supply. It is a 220 or 230 volts RMS value. You get that? This is RMS
Yes.
value.
Yes.
Root mean square value. And it has another specification. We will call that as a 50 hertz.
Okay.
Have you noted this? Have you ever noted this 50
No.
hertz power? Okay, so we will come to that. But what I am trying to say
220
here,
volts I've heard because in physics questions we had it, but 50 hertz no, I didn't.
we will come to that. That why
Okay.
there is a hertz and why that is another specification for a AC means alternating current. DC means direct current. Okay,
Okay.
and AC means alternating current. We need to ask question, keep asking question, all of this. Maybe they are all new for you. Even though you are seen a sign, this is actually you might have learned as a sin X, right?
Yes.
Probably drawn for the x-axis. And if you drawn it on the t-axis, then it will look like a sin t. Okay, sin t function looks like this. Okay. So here the t, ta and the tb, capital T, mean if it is straight away written like that, it is for temperature.
Okay.
Okay, and the temperature, there are two temperature here, Ta and Tb. Probably a temperature of a chemical A and a temperature of a chemical B. Do you get that?
Yes.
That is the right side bottom corner, small letter subscript. Always, never ever think like it is something like same as the top right corner subscript. Okay.
Okay.
So I have done it purposefully for you to understand that. Okay.
Okay.
So that is very important for everything. Okay, let's move on. Like so, the other day, last week, we learned. Okay, let's recall that. Let's see, log m to the base n. What is the meaning of this?
It is
Okay, so don't force yourself like you should have memorized or you should have remembered. That is not the point here. If after a week we are asking the same thing what we discussed a week ago, and at that time you had a good idea, right?
Yes.
I thought so. You also thought so. But now after a week, when I asked about that, you could not get the answer straight away, right?
Yes, uncle.
Okay, so what it has to be done, then the question, like we have to help ourselves. For you, you have to help you, because I know about this, I have an understanding about that, because I am too much experienced, because I am 50 years old. What, you are 15 years old?
I'm 16. Yes.
16, okay, let's say 15 and 50. I have a 35 years of extra experience, and I have learned logarithm, and I have been using almost every day with that, one way or the other, either for my research or for my teaching or everything. So my understanding is a experience, is a mixture of, I remember that, and also always I used the basic knowledge about something, and I have developed that, and I thought about what is logarithm by connecting that. Okay.
Okay.
So now, a week ago it was all clear. Now after a week, when I write something like that, it is not immediately coming into your mind, what is this? So now what you should do, you have to take a step back. Okay. Think for what reason actually we have brought this log as a mathematical function or operation. Let's go from there, right? Because there was some kind of understanding. We went from addition, subtraction, like equal and opposite operation, right?
Yes.
Then, okay, let me write it like on this side. Okay, so we learned addition and subtraction. Then from there, we went from the addition, we went repeated addition, right?
Yes, sir.
Repeated addition is called multiplication, right? So that this become the multiplication. Then immediately we need to have a opposite for that. So the opposite is, the other side is division. Okay, so this could look like this symbol, or it could be a slash, or it could be a horizontal line, right? So
yes.
This is a division. Good. Now these are all the things we have learned. We have gone still further. We thought about, can we repeat the multiplication? repeated multiplication, right?
Yes, uncle.
What that is, how that is represented? Because we have a representation in mathematics, right? Addition looks like a plus. Multiplication
Yeah.
looks like a cross or a dot or a bracket with two different variables. Or even you write AB, A is a variable, B is a variable, they multiplied with each other. Like that, how to represent a repeated
You're asking
multiplication?
repeated multiplication as in the same number repeated, or
What will get repeated? Okay, repeated addition, what is the understanding here? Because you cannot, you see, you are developing your understanding, Karishma, okay?
yes,
You have to be clear with that, because now you want to have a clarity about my own question, isn't it? That is why you are asking repeated multiplication means repeated with what? What you can repeat? Like repeat means what? You did not ask the question when I said repeated addition is a multiplication, right?
yes.
Give me a multiplication example.
So 20 into 5.
20 multiplied by 5. Tell me what is the meaning of this? It's a meaning in terms of repeated addition, because we agreed and you have an understanding multiplication means repeated addition. You are okay with that, right?
Yes, uncle.
Then how to tell this multiplication operation mathematically represented as 20 cross 5. We know that 20 is multiplied with 5. What is the equivalence in terms of repeated addition? Because multiplication, so this symbol, instead of this symbol or
Yeah.
the multiplication representation, multiplication arithmetic operation, that could be made as addition, right? Repeated addition,
20
right?
plus 20 plus 20 plus 20 plus
Okay, 20 is getting repeatedly added with itself. Do you get that? You
Yes.
cannot ask what is repeatedly added with what. So if
Okay.
you count how many number of times this is 5 times addition. Do you get that?
Yes, uncle.
Or the beauty is, I mean, this is also equivalent to like 5 add with itself repeatedly 20 times is equivalent,
Yes.
right?
Yes.
That's the understanding. There is no question about that. This is very basic. Otherwise, you have not understood what is a multiplication means. Do you get that?
Yes.
Repeated addition is the multiplication. Understanding has to be very clear. Now, repeated multiplication means how it should be. First, can you give me the example of repeated multiplication? Let's come to the representation in mathematics the other way. Because I am asking, I first
Okay.
gave you this, right? From here, from multiplication, this is multiplication. Then we went to repeated addition,
5
right?
into 5 into 5. So it will be
5 multiplied by 5 into 5, for example, 3 times.
yes.
How to write this? That is, what
5
is the
to the
representation?
5 raised to the power 3.
Okay, that's it. Do you get that?
Okay. Yes.
You cannot question that what is repeatedly getting multiplied. The question is okay, not to me. You should question yourself. You should have an understanding out of that. Do you get that?
Okay.
That is how you develop your confidence. That is how you develop your knowledge to not stay with like, okay, I can do only these mathematics, and beyond that, that all become advanced. I need to go and revise. I have to look into it. The question comes about, there is nothing wrong with not remembering the log. There is no problem with that. But the problem, what I am suggesting you here is, you have to connect back. You have to take a step back from where this log function or the operation came into picture. How that has
Okay.
come into picture. That understanding, you cannot give up on that. That should be the basic. It's not simply log m to the base n. Straight away, you don't need to remember about that. You don't need to memorize that. Do you get that?
Okay.
Like from addition, if you understood very clearly what is addition and how it goes to repeated addition as a multiplication, and repeated multiplication as a rise to the power of or exponent or index, then what is the opposite side of that? Roots, right?
Yes.
Okay, the other side is, for example, if you want to like the cube root of, okay, there is something called the cube root of something like 8, then we just write the 8 into, split into equal parts, but
Yeah.
repeatedly multiplying them should become a 8. So we split into 3. Do you get that? So we write the cube root of 8 can be written as a 2 times 2 times 2. Why we are doing that? Because this cube root is asking, can you split the number which is operated by the cube root into 3 equal quantities, so that the multiplication of the repeated that quantity should be 8. Do you get that?
Yes, uncle.
Are you clear with this?
Yes, yes.
Okay, then the cube root we can write that as a 2 power 3. So that is equal and opposite. So this will give us 2 raised to the power of 3 over 3. That will become a 2. You get that? So that is the answer we are looking for. Cube root of 8 is a 2. That is also fine, right?
Yes.
So you see the hierarchy of how this has expanded this side and how the mathematics have helped us to have an opposite also for each of them.
Yes, uncle.
Right? So we have discussed about that. Any questions or doubts so far? Hello?
Yeah, no doubt, uncle. Okay.
You are writing something notes?
No. I did tell it. Can you hear me now?
Yeah, I can hear you, but
Okay.
you are not immediately answering that any questions or doubt. So I am questioning whether you are taking notes or something.
I was, but then I did tell it first time itself once you asked. I don't know what happened.
Okay, so now we went from addition, subtraction, multiplication, division, for example, then x raised to the power of a, then what is the nth root of m, something like that. Okay, these are all like different hierarchy level. In this whole set, something was missing. That was discussed with the understanding, let's say, like if you have something like y equals x raised to the power of a, right?
Yes.
Then we discuss in mathematics everything. We need to know that if an equation like this written, we need to know that this here the subject is y is the subject, right?
Yes.
Subject is y. Then we should know how to write in the other subject. Let's say change subject to x, for example. Then we look at this. What is the first step?
Get x to the left hand side.
We swap it because we looked at it where our subject we are interested is on the right hand side. We first swap it. Then we look for when you write a subject like y means this is actually y raised to the power of 1. So we need to have a quantity on alone as a subject only if the power is 1, if the multiplication is 1, if the division is 1 and addition is 0. So we are asking the question whether the x is like that. No, x got something attached with that. What is that? X raised to the power of a. What is the meaning for that? X is repeatedly multiply itself 8 times. How to make that a, the rise to the power of a, to become a 1? That is how we need to develop the idea about what step has to be done next, so that I can have only x on the left hand side, right? That can happen only if the power is divided by the same quantity. You get that?
Yes, sir.
And that makes us y raised to the power of 1 over a, because the previously here this is nothing but y raised to the power of 1. As the left hand side whole quantity power is divided by a, we have made some disturbance to the equation balance, the equal sign balance. So we need to do the same operation on the right hand side also. Are you with me?
Yes, uncle.
Okay, so this a and a we did this purposefully to make the power to be 1 for the x. That makes us y raised to the power of 1 over a. The other way of representing this is a root of y. Are you with me?
Yes.
So what else is missing? Like we have a subject as a y, we discuss about that. Subject as a x, we discuss about that. What is the third possibility? Because this whole quantity is made of 3 different variables, right?
Yes, sir.
So what is the third possibility? This is possibility number 1. This is possibility number 2. What is the third possibility?
Is it y to the base x?
Don't post the question back to me. Go back to our discussion. What we are looking at, what we are dealing with. Read it again. Can you tell that?
Y is equal to x raised to the power of a.
Okay, tell me what is this? Very basic about what is this? Y equals x raised to the power of a. What is this?
Which one?
Simply, if you are seeing y equals x raised to the power of a, what is coming into your mind?
Yeah, x is multiplied a times to give y.
No, that is all finer details. If you see y equals x raised to the power of a, what is the one thing in mathematics which can capture everything here? You cannot split only the x power a. You cannot split only the y. If you take only x power a, then you are forgetting about y equals, right?
Yes.
If you consider only y, then you are forgetting
An
equals. It's an equation.
Okay.
Don't ever forget that. You
Okay.
see, Karishma is very simple. Okay, I mean,
Yeah.
if we are taking care of everything about what we are seeing, what we are given with, what we are provided with, then we are well and good to ask all the question to understand everything. That will give you the fantastic idea to go with a lot of steps and procedures to derive lot of things out of that. Do you get that?
Yes, uncle.
If I give you only a bread slice, what you can do with that? Can you make a sandwich?
No.
Do you see that?
Okay.
So if you have a something in mathematics which is rich of so many things, so many details, that will give you lot of opportunities, right, to do something with that.
Yes.
So some people always think that simplicity is easier. Easier means there is nothing there. What you can do with that? I will give you an example. I give you a. What you can do with a? Tell me. Can you tell me whether it is an English alphabet or a mathematical variable? What you can tell about a?
No.
Nothing. What is interesting about a? Nothing. But it is very simple, right? Very easy. Is
Yes.
a. We want to stay with that? No. This is not helping you at all.
Yes.
Isn't it? But y equals x raised to the power of a, it is beautifully telling lot of things here. First of all, it is an equation because there is an equal symbol.
Yes, sir.
Right? In the equal symbol, then what is the equal symbol means? Equal symbol must have two things, because equal symbol is a binary operator.
Left hand side and a right hand side.
Yeah. Then we see that left hand side is a simple y, is a single variable on its own. That meaning it is raised to the power of 1 multiplied with 1 divided by 1 added with 0. Do you get that?
Yes, sir.
And on the right hand side we have x raised to the power of a. It is actually made up of two variables, x and a. But tell me completely one mathematical thing which can completely take care of the whole right hand side of this equation. Do you follow my question?
Could you repeat it?
Yeah, tell me, because you need to connect you need to connect what context we are talking about, right? We are talking about the context of a mathematical equation which is y equals x power a, right?
Yes, uncle.
And we went to the finer details. Why it is an equation? Because there is an equal sign. Equal sign is what? Binary operator. It needs two operands. And we discussed it is a left hand side and a right hand side. And the first operand, we always look into the left hand side, and also in this case it is simply y. So simple operand will be looked into first. Okay, y. Then what could be the next question? Tell me. We have seen that this is an equation because it's an equal sign. Equal sign should have a left hand side, right hand side.
Yes.
So we look into the left hand side. What will be the next question, or what will be the next thought process?
So what does that A mean?
No, the right hand side completely. Do you get that?
Yes.
Karishma, you see, you have some knowledge, you have good basics. You are trying to get the answer. Target is not the answer alone. Do you see that?
Okay, yes.
Do you see what I am helping you? Because I think we are meeting for 7th week or 8th week. Do you see what I am trying to help you? Most of the things, except the logarithm or the inner details about how to think, the critical thinking and analysis, those are all the things I am teaching you. Do you get that?
Yes, sir.
And you have to catch that. If you leave that, then you are not learning anything from me. Do you get that?
Yes, yes, sir.
And I told you, answer is okay. But tell me, okay, I will give you a simple problem. 1 plus 2, you learned it. What is the answer?
1 plus 2 is 3.
3. Good. You know that, right? You learned it long time back.
Yes.
And you still know, you still remember and everything. And if you still think like 1 plus 2 equal to 3, okay, I know that, I got the answer, end of it. Do you think that it is good enough for you at this age?
No, no.
Okay, now tell me, you have written 1 plus 2 equal to me. You have told me the answer is 3. I put the equal sign. You did not tell me equal sign. 1 plus 2 is 3. That is what you said. But I wrote it as a equal to 3. Now tell me, at this age, with your experience, what are all the things you can tell about? Mathematically, explain everything what you can understand here.
Okay, so this is an equation first.
Good. Yeah.
Which has a left hand side and a right hand side.
Because equal sign should have a left hand side and a right hand side. Meaning it is equally balancing both the sides. So the content of the left hand side has exactly balanced to the content on the right hand side. That is the meaning of the equation, right?
Yes, yes, sir.
Okay. Then go to the finer details. Now we understood it is an equation. We have an understanding that can be explained to other people also to appreciate that. Now equal symbol should have a left hand side content and a right hand side content. That is also understood. Everybody will appreciate that. No question about that. Now finer details. Left hand side has to be dealt separately, looked into separately for the finer details. What is the left hand side here?
So first an operand, which is addition, is used in the left hand side.
Yeah, addition is the only mathematical operation that can explain completely about the left hand side. Do you get that?
Yes.
Because plus symbol needs its own 2 operands, left side and right side operand, right?
Yes.
That is actually bringing what is the left side operand, that is 1, and the right side operand is 2. So that gives the full picture. Addition is the left hand side, that is actually adding 1 with a 2, right?
Yes, uncle.
So whatever is the 1 added with your 2, when you see it on the right hand side got a simple single number 3. Do you get that?
Yes, uncle.
That tells that 1 plus 2 can be simplified, added together, and you can get an answer as a 3. That is what this is explaining.
Yes.
More than that, when you can simplify 1 with a 2 addition as a 3, tell me when this can be possible and when it can be balanced.
When both are the same unit, like
with both, you see that like 1 and 2 are the 2 operands, 2 different numbers, 2 different the quantity, the magnitude is different. Do you see that? 1 is 1 amount, 2 is 2 amount. We say that mathematically this 1 amount can be added with the 2 amount to give an answer as a 3 amount. When this is possible, only the 1 amount and the 2 amount must be the same, then only it will give you the 3 amount of the same. For example, 1 apple plus 2 apple equals 3 apples, right?
Yes, sir.
Then this is the way we grow up, like we develop the understanding. Now the 1 and 2 can add together and simplify as a 3. The subject can be changed. It looks like 3 is resulted from adding 1 and 2, right?
Yes.
The other possibility is, the answer 3, like, okay, I will go to the other page, clear all this. So 1 plus 2 equals 3. We should have the understanding these two things actually merged to become a 3. But we should know that if I want to have only this 1 as a subject, what happened to the 1 added with the 2? So subtract 2 on both sides. You get that?
Yes. Yes.
So that will make 1 plus 2 take away 2 equals, we did something on the left hand side, 3 take away 2.
3 minus.
Right?
Yes.
So the plus 2 and minus 2 mean immediately the number line also comes into picture from the 0. Plus 2 is 1, 2 division. This is plus 2. And this, if you go back in the opposite direction, this is minus 2. Do you get that? So you will go back to 0. So that is why we did this. Because we don't want this plus 2 to get with the 1. We want only 1 to be written. So 1 is nothing but 3 take away 2. You see that?
Yes.
So the other thing, okay, I want only 2 here. Then one need to do subtract 1 on both sides. If you want the 2 alone from here.
Yes.
So that will tell us from here to here, that is 1 plus 2 minus 1 equals 3 minus 1. So 1 and 1 can be cancelled. That will tell us who is actually 3 minus 1. Do you see how to recover? We started with adding 1 with a 2 to get a 3. But full understanding and everything will help us to do all these things, to understand what are all the things happening, and even the subtraction. If you can subtract 2 from the 3, 3 and 2 should be of the same type, then only it can become one amount of that same quantity. Do you get that?
Yes.
Like this, when we go higher and higher, it's not higher actually. The understanding has to be developed. Y equals x raised to the power of a. So we told that there are 3 variables. It is an equation involving 3 variables. Equation means an equal sign is there, which has a left hand side and a right hand side. Left hand side is simply a y. That's why this equation is a subject y, right?
Yes, sir.
And there is a possibility to rewrite this mathematically, doing the right procedure, correct procedure, and the inverse procedure, or whatever the steps that has to be followed from the information provided. The other 2 variables are what? We can write this equation in terms of subject as a x and the subject as a, right? So this is possibility number 1, subject as a y, which is already given. Do you get that?
Yes, sir.
Second is subject is x. That we did it. Swap it, x power a equal to y, x power a over a equals y power 1 over a, 1 multiplication factor, x is y power 1 over a equals eighth root of y. Done, right?
Yes, uncle.
Now what is the third possibility? Still not catching this, right?
Yes, uncle.
Go back to the thing. Where we started with, what we have been provided with. We have provided with only a sandwich here, or only a bread slice here. Where we started? Tell me what we are talking.
We're talking about. We're talking about x raised to the power a is equal to y.
Yeah, what is that?
Okay, an equation.
Okay, equation involving what?
Involving repeated multiplication.
No, you are going into other side. Okay, they are all okay, Karishma, but this is an equation involving 3 variables. Do you see that?
Okay. Yes. Yes.
Or 3 quantities, like we discussed, 1 plus 2 equal to 3. This is an equation involving 3 quantities, 1, 2 and 3.
Yes, this is involving 3 variables.
The mathematical operation is actually making the 1 and 2 to become a 3. That is why we have written that as an equation. Do you see that understanding?
Yes, uncle.
Like that, y equals x raised to the power of a means it is an equation, of course. Equation of what? Involving
x and y. And
only
a.
x and y.
And a.
Why a is not important? Why a is looking like a why you are discriminating a? Tell me. You don't like a or it is written as a small font size?
No. That is also
Your
It is
thought
also
process is not giving the same importance for the A as you give it for the Y and X. You agree with me or not?
yes.
Tell me why. Ask the question to yourself. What makes you to do so? Do you think that without that A, this whole thing will make any meaning?
No.
Then what is which one is important? If you write like Y equals X raised to the power of A, in this there is some kind of reservation here or discrimination here.
No.
Everything is important, right? We cannot neglect
Yes.
any of this. There is no hierarchy or like, okay, this is more important than the other thing. Nothing like that.
Yes, sir.
Do you get that? So you need to remove that partial consideration or something like that in anything, okay?
Okay.
You see that, like, okay, I mean, you tell me what Indian food you like. Like, okay, for a lunch, what you like the most? What is your favorite food?
I like pizza.
No, I said Indian food.
Indian means okay. And biryani.
Okay, biryani. Okay, tell me. Okay, I mean, it's like only one thing is more important than the other, so that the biryani can be made.
No.
No way, right? Even your pizza. Okay, pizza may have the cheese, may have the base, may have the tomato sauce, may have the maybe the some meat content or vegetable contents, onion, everything will be there. But can you give more importance to one compared to the other?
No.
Right? Okay, I mean like
Yeah.
that, like that. Y equals X raised to the power of A. You should not look anything like X and Y are more important than the A. Do you get that?
Yes.
So if a equation contains three variables, then what are all the three possibilities? Tell me.
When an equation contains three variables.
Like we discussed about the 1, 2, 3, right?
Okay.
What we did here, what is the subject? The isolated item is the subject, right?
Yes. So Y is the subject.
Okay, like 3 is your biryani. 1 could be the rice and 2 could be the meat. We are talking about the major ingredient, right? You take the
Okay.
rice and cook with the meat. That will give you biryani. Do you get that?
Yes.
Then, if you ask the question, what is rice? You can tell that the biryani, remove the meat, it will be the rice. Do you get that?
Yes.
What is the rice? The meat. I mean, take the biryani, remove the rice, that will be your meat. That is what mathematics is.
Okay.
Okay, like that, you have Y equals X raised to the power of A. What is the understanding? It is an equation made of three variables, X, Y,
Yes.
and A, right?
Yes.
Then what are all the three possibilities here?
The three possibilities is
Yeah, in the given form, the subject is Y, right?
yes. The subject is Y. Yes.
Yeah, then what are all the other two possibilities?
The other two possibilities are X and A, but I'm not
Yeah,
sure how.
subject X we have done. That is why I am asking what is the third possibility. You are not answering me. What is the third possibility? Subject?
Or subject A.
Subject A. Until you give importance for the A also equally with the X and Y, you will never get this question, okay?
Okay.
Now tell me how to make the subject A from the equation. Given equation information is Y equals X raised to the power of A, right?
Yes.
What is the first step? Tell me.
Okay. So first step is swap the.
Swap it. X raised to the power of A equal to Y. Now what we have to do so that the subject can be A? Do
The
you see that?
subject should first now it should come to the base.
Exactly. So you see that tells us automatically the step or the procedure will come into picture to our knowledge, and we will do it with confidence, the correct mathematical operation to get the job done. Do you get that?
Yes.
Then how to bring the A to the base? So that is asking the question, what is the meaning of this A? A is
Okay.
actually telling X is getting multiplied repeatedly itself A number of times.
Yes.
Do you see how beautifully the problem is telling us what to be done?
Yes, uncle.
Okay. So the question is, if I know x power a equals x is repeatedly multiplied a times, this is the understanding, right?
Yes.
What to be done to this x power a? So I need to do something on this. If you add with, okay, a is looking like here. If you divide this by a, it's not helping me, right?
No, it's not.
It's not helping. Okay, take x power a, you subtract with a, that is not helping. Subtract
No.
x, even divide by x. Subtract, nothing will happen because it is sitting on the a. Do you see that?
Yes.
All the known mathematical operation, addition, subtraction, multiplication, division, or rise to the power of, you have x rise to the power of a, you make again, you apply another power x, this is also not helping. Because we
Yes.
want a equals, this is what we are questioning. Do you get that?
Yes.
You see, we need to appreciate our question itself. So that makes us clearly, whatever the thing we learned so far, we understood clearly so far, starting from addition, subtraction, multiplication, division, rise to the power of, it is not helping us in x rise to the power of a equal to y to make it like y equals what. Do you get that?
Yes.
So how to do a mathematical operation to get this job done? I told you, I mean, the Napier, he just looked into,
Log.
okay, if I have x power 1, that is my x, right?
Yes.
So if I'm asking, I want 1 to be my only thing, 1 should be equal to in terms of these x and x. Do you see that?
Yes. Yes.
That is the question, right? If I know x power 1 is actually equal to x, I know this is right. So I want this 1 to be expressed in terms of the 1x on the left hand side of the equation and 1 on the right side of the equation. So he used the knowledge like x raised to the power of 1 is equal to x. I want to operate this x power 1 with something, a mathematical operation, so that the answer will be 1. Because that is the one he is asking for. So what he did, you need to use the other side quantity also. Do you get that?
Yes.
So he just said, I will write that as a log to the base x. He just made a new mathematical operation for that. He invented that. So this tells us a log x power 1 is nothing but the x itself, right?
Yes.
So the base x is actually 1. So if you take the log of a quantity to the same, the base itself is a 1.
Okay.
Okay, so the question is, what is the meaning? What is the thing going on with the x and the x? We are questioning the logarithm is coming with a base quantity. We are asking from the base quantity x, look at what is the log is operating on. We are asking how many times the base quantity can fit into this operand.
Okay.
Okay, so the log is written as a base quantity and a operand because it has to operate on something, right?
Yes.
So from the base point of view, this base is questioning the operand. Can you split it? Base is asking the operand, can you split yourself into my times, like base times multiplied with base time. If you do so, then how many times you can split yourself equally, so that if you multiply all of them, the answer should be operand. Do you get that?
Yes.
Do you follow that? Do you appreciate
Yes.
that? Going
Yes,
on.
uncle.
So that is the reason when you write log x to the base x, from the base x point of view, you look at the operand and the question how many times as a multiplication factor the x base can fit into the operand x. That is straight away 1, right? 1 amount.
Yes.
This is what this one is. Okay.
Yes, uncle.
So this is also right?
Yes.
You get that?
Yes, uncle.
Okay, now I write log 3 to the base 3. What is the answer?
Log 3 to the base 3 will be 1.
1. Now log 3 squared to the base 3. What is the answer?
2.
2. Do you see that beauty? Because
Yes.
the log 3 is the function acting on this 3 squared. Do you get that? Now
Yes.
the log function is simply asking the base quantity, can you look into this whole operand? How many times this operand can be split into the base times? So we are asking the question, 3 squared operand should be written in a base. This base is used here. 3 times 3. That is what 3 squared is. So this is 2 times.
Yes.
That is the answer coming to here. Right?
Yes.
So now go back to the question I asked today. Log m to the base n. What is this?
Okay, so log m to the base n will be
Who is asking what?
yeah, so the base quantity, which is n, it should fit how many times it can fit in m.
That is the thing. Like if you can write m in terms of n multiplied by n multiplied by n, let's say if you do this, if this is possible, count how many number of times.
How many
for
times?
example, 8 times. If this is possible, then we can write this as a.
A.
You see that how this is connected?
Yes.
You can make it as an equation only if you can get this job done between m and n. This is similar to like if I ask the question 1 plus 2 equal to what? You could do this operation, right? Addition operation, right?
Yes.
Addition operation need 2 operands. That is actually 1 and 2 in the given problem. Then you add 1 with the 2 to give an answer 3. So something has to be done between the quantity 1 and 2. You know what is addition, you get the job done. Same thing. If I write log m to the base n, we are saying this plus is equivalent to this log. Do you get that?
Yes.
In this case, addition is the mathematical operation. In this case,
Here,
logarithm is the mathematical operation. In this case, one operand is 1 and here this one operand is n. Here one other operand is 2. Here the other operand is 2. You know what is the meaning of addition, how that can be done between 2 quantities like 2 numbers 1 and 2. You get the job done. Same question. Logarithm means what? The base of base quantity. This is asking the question. Logarithm is asking the question, whatever the base, look from the base point of view, whatever the log operand is, can you split this m into n number of quantities, n repeatedly multiplied with itself. So the repeatedly multiplied part is contributed by the base. Do you see that?
Yes, uncle.
And all of them multiplied together must equal to m, that is the operand part. Then if you know this value, how many times this n is, the base is repeatedly multiplied, so that the simplified form can give you the operand value, then this A is our answer. Right?
Yes, uncle.
Okay, let me quickly question you. Let's see whether you can solve that. Log 25 to the base 5.
2.
Okay, write it step by step. Log 5 to the base with power 2. Because
Power
the
2.
base has to be looked straight away here. Then this form will be helping us actually. Once we get this, we know the answer is 2. But better to write this 2 to the front. 2 multiplied by log 5 to the, because this one will be, this one actually meaning now the power is 1. So we know that this whole quantity is equal to 1. So this becomes 2 multiplied by 1. Answer is
1.
2. The thing is okay. Straight away you got the answer, that is equal to 2. Good. But there is a procedure happened here. Do you see that?
Yes.
Okay. So like this, like let's say you have log m multiplied with m base m. Answer is? It
will be 2.
2. Okay. Okay. So I will quickly expand this and tell that there is a thing going on here. Now you see, m multiplied by m, the whole operand is actually m squared, right?
Yes, m square.
But if you see that, like if you write it as log m multiplied by m is actually equal to log m squared to the base m.
Yes,
This 2 can be brought to the front, right?
Front.
2
Yes.
multiplied by log m to the base m. We know that this whole thing is a 1. This is 1. That's okay. But do you know the understanding of what is happening between the 2 and the log m to the base m? What is the mathematical operation going on between these two?
Is it multiplication?
Right?
Yeah.
Right? 2
Yes.
times log m to the base m is what? Repeatedly adding log m to the base m by itself.
2
Do you
times.
get that?
Yeah. Yes.
Log m to the base
Into the base m plus log m to
base
base.
m. So do you see the beauty? So this log, we started with the log m multiplied by m to the base m. This can be written as straight away log m to the base m add with log m to the base m. Do you follow this? You have a log x power a to the base x. The answer is
Answer is A.
a. You see, the log is actually reducing the position of, or whatever the mathematics, the index has become a normal multiplication. Do you see that? Actually 1
Yes.
multiplied with a. Do you see this?
Yes.
So
Sir.
the reduction, so the log will actually reduce the, like we went from addition to multiplication is repeated and rise to the power of, do you see that?
Yes, uncle.
These are all repeated, like repeated addition, repeated, this is repeated multiplication. So if you take the log, this will actually, the log will take the rise to the power of to a multiplication. If there is a multiplication, the log will make it as a addition. Do you see that?
Yes, uncle.
Here you see the multiplication. Log m multiplied by n. The operand is having a multiplication, but that's split into an addition.
Yes.
You get that?
Yes. Uncle.
So final thing, let's stop here. Log x y base a. How you can write this?
Log xy to the
We
base
know that what is
A.
log a, right? Log a is asking for, logarithm is asking for, look at the base.
How many times A can fit in x and y?
Yes. What is happening between the operand x and y?
Multiplication.
Then don't you think that this can be written as a log plus log y to the a? Because we just did that, right, in the previous
Yes.
case. Yeah,
Yes.
multiplied
Yes, uncle.
down.
It can be written. Yes.
But it can be written. But I'm just saying this. We proved this, right?
Yes.
We proved this, right? I'm questioning you. Can we prove this also? Like this we proved because we know that this can be written as log m squared to the base m. This is nothing but 2 can be brought to the front, 2 log m to the base m, which is actually, this is actually equal to 1. So that is why 2 multiplied by 1 is a 2. We did that.
Yes.
And from there, this 2, this whole quantity we split into 2 pieces. Addition of log m to the base m with itself. That actually proved this.
Yes.
We have written this whole quantity 2 multiplied as this one part, 1 time, 2 times. You get that?
Yes, uncle.
Then this proved this. So now think about this. We will discuss next week. Okay?
Okay.
Because what I'm trying to see is we are discussing and we are making ourselves fit enough to understand what is going on. What we know about that, can we use our basic understanding of what is going on? Can we prove or solve the given problem? Do you get that?
Okay.
So what sort of question you will ask for proving this? That is the thing I am questioning you.
Okay.
This is not complicated. If you have understood all the things what we have discussed and can you make use of that, then proof this is very easy. Okay.
Okay.
Okay. So there are two things we can prove, like log xy to the base a can be written as a log x to the base a plus log y to the base a. Similarly, log a x over y can be written as log x over base a. Take away log y to the base a. Two proofs. Proof number one, proof number two. Okay, not difficult at all. If you have understood what is log, what it is doing, how this is helping us to do some mathematics, then we can prove this. Okay.
Yes, uncle.
Thought process, the critical thinking is very important. Analysis is very important. That leads to a good understanding about what is given to us. And from there, with our understanding and the knowledge we already have about the log and what it is doing for the operand with the base and everything, anything can be proved and any problem in that particular log can be done. Same thing with any mathematics or any problem in physics or chemistry or biology or whatever it is. Do you get that?
Yes, uncle.
I want to see that how broadly you expand your thought process and use the knowledge, not simply jumping into, okay, I want an answer. I want an answer. You can get an answer, right answer. But I mean, you are the first time getting the right answer. People have already done that, right?
Yes.
Why you have been asked to do this again? Do you think that you are the first person to prove this? Not at all,
No.
right?
No.
But why you have been asked that? Because you have to learn what is involved with this, what is the understanding, and when you can use it when similar kind of problem is appearing in front of you. Do you get that? For that, understanding is the base, not the answer. Answer may be right or wrong, but why you are doing that, why this problem has been asked to you to be done, why you are learning logarithm, where it could be used, what is the meaning of that. That is how you need to ask question about everything. Okay.
Okay.
Okay, then we will see next week then.
Okay, uncle. Thank you.
Stop. Okay. See you then. Bye.
Yes. Thank you.